Welcome back to another lecture from organic chemistry. In this lecture, we're going to go through alkynes. In alkynes, we will have a triple bond. That means there will be a unsaturated carbon, and degree of unsaturation, it will be 2 because we have 2 pi bonds. So the first one, it will be sigma bond, and then we have two pi bonds. Okay, so we have 2 of them, 2 pi bonds, and we say degree of unsaturation, it will be equal to 2. Okay, the hybridization, whenever you're talking about alkynes, it will be sp. Okay, so any carbon that's involved in the triple bond, it will have sp hybridization. It means the bond angle, it will be 180, and the system will be linear. Okay. And let's go through how to name actually those compounds. And the rules, it will be similar to alkenes. And you need to start with a triple bond. Triple bond should have the smallest possible and locator or number. And your main change must include the triple bonds. Okay. So, for example, when we were talking about the alkane, we said we have a saturated system, and in this case we have 5 carbons. So we said pentane. Okay, pentane, AN stand for saturated system. And then we made a double bond. Now that we have a double bond, okay, we change AN to EN. Okay, so now we have EN. And whenever we switch to a triple bond, it will be replaced by YN. Okay, YN to say that we are dealing with alkynes. So this one will be pentyne. Okay, and next, your main change or the parent change must include the your main change or the parent one not only must have the like the biggest number of carbons, also should include, okay, or must include the triple bonds or the double bond. Okay, so in this case, I'm going to say this one, it will be the parent chain because it's including the triple bond. And well, for the alkane, we said this is going to be the longest chain, and because it has the biggest number of carbons there. And well, for the alkyne, we switch to the triple bond, because the triple bond is not included in this side. And so that one, it will behave as a substituent or alkyl, and you need to say that this one is attached to the system. Okay, how do we name them? Okay, we start labeling them from the side that is closer to the triple bond. So as you see, we started from here. Why? Because the triple bond is going to get 2, and it will fall between the second and the third carbon. But if we start from the right side, it will fall between 5 and 6, and that's not going to be correct. So you get the smallest possible locator to the triple bond, okay? And then you will be worried about the substituent, okay? Now, in this case, if I want to name this compound, okay, so let me grab this structure and go after the naming. Okay, and I have totally, I have 7 carbons inside the main chain. So this one, it will be hep. I'm supposed to say heptane for saturated compound. Okay, for saturated compound, I'm supposed to say heptane. Okay, now we're going to replace ANE by YNE. Okay, so we're going to replace it by that one. Okay. And this is going to turn to heptyne. Okay, heptyne. So now I know the name for the main and change or the parent one. Okay, I have substituent. I have a methyl one there, and I have 2 methyls here. Okay, so I'm going to say on the 5th carbon, comma, on the 5th again. Okay, per each substituent, you need to write 1 locator. And I have another one on the 6th carbon. So I have 3 carbons there, and I'm going to say tri. Why tri? Because I have 3 carbons. Trimethyl. Okay, I'm going to add YL to it to show that it's attached. Okay, attached to where? Next, you need to show position of the triple bond. Okay, and I'm going to say on the 2nd carbon, I have a triple bond. So I say 2. And then the main chain, it has 7 carbons. So this one, it will be pentyne. Okay, pentyne. Okay, I can rewrite the name, okay, this way. Okay, so let's keep the first part and then change this section. We're going to say we have 5, 5, and 6 trimethyl, and then we say let's write the name of the main chain. It has It has 7 carbon. Forgive me, I keep saying pentane. It's heptane. I'm sorry about it. It's heptane. Hep. So this one will be heptane. Okay, and then I'm going to say hep. Okay, hep for 7 carbon, and then you say dash. There is a triple bond. Where? On the second carbon. And then you say dash, and you add YNE. Okay, YNE. And this one also is going to be a correct way to name the compound. And as you said, we have 5, 5, and 6 trimethyl 2 heptine, or you can say 5, 5. Okay, 5, 5, 6, and then trimethyl hept, and then dash 2 to show the position of the triple bond. Okay, and then YNE to show that we are dealing with a triple bond. Okay. There are some common names for alkynes. Okay, and we have 3 molecules here. I'm going to show the common names for them. Okay, the first one we call it here methyl acetylene, and the second one we have 2 groups that they are identical. So if I go back here, okay, this one we have methyl. Okay, and the methyl is attached to acetylene. Okay, and next one, these 2 groups are isopropyl, so isopropyl, and I have 2 of them. So if I want to name this compound, I'm going to say this is diisopropyl. Okay, diisopropyl. Okay, and is attached to acetylene. Okay, so it will be diisopropyl and attached to acetylene. Okay, and the next one I have a phenyl. Okay, this one is phenyl, and that one is propyl. Okay, now I want to mention those 2 substituents that attach to the triple bond. Okay, and now I'm going to start with phenyl because it's pH versus PR. So I'm gonna name it this way. Phenyl. Okay, this one comes first, and then after that one, I'm going to say propyl, and last one I say acetylene. Okay, this is another way to name the compound. Okay, do I have another system to name them? Yes. How about this? Why don't you start with here 1, 2, 3, 4, 5, 6, and so you have 6 carbon and 2 substituent on the second and the 5th carbon, and the triple bond on the between the 3rd and 4th carbon. So you can say on the 2nd and the 5th, I have 2 methyl groups. So this is going to be dimethyl. Okay, dimethyl, and what else? In our chain, it has 6 carbon. So this one is supposed to be, okay, 6 carbon. It will be hexane if it's saturated. And where is the triple bond? It will be on the 3rd carbon. So I go 3 hexane if it's saturated, but it's not. Clearly, I have a triple bond. So I say 3 hexane. Okay, or you can say 2 and 5 dimethyl, and then say hex dash 3, and then you say YNE. That's another way to name the compound. Okay, if the triple bond is sitting at the beginning of the molecule, we call it a terminal. Okay, or at the end of the molecule, we call it terminal. But if it's somewhere in the middle, then it will be in internal. Okay. And how about the acidity of the alkynes? So we have alkane, alkene, alkynes, and in that case, you have to look to the hybridization. This is sp3. The carbon is sp2, and here we are dealing with sp. Electronegativity of sp is higher than electronegativity of sp2, and that's higher than electronegativity of sp3. So that means if you create a negative charge on the acetylene is more capable of handling the negative charge. Okay, why? Because it has a 50% S character. And the more s character you have, the closer the system will, the closer those electrons will be to the nucleus, and it will be more, it will be stable with more amount of, you know, like force. Okay, and here we have 33% s character, and that one is only 25 s character. So I'm going to say the higher stabilization you get, the stronger the acid will be. And because sp is more capable of handling the negative charge, it will be the strongest acid between these three compounds. Okay, so acetylene, it will be the strongest acid. Okay, now, is it possible to transfer H to another compound when you are dealing with acetylene? Yes, and like it depends to the base, the acid basicity of the base. Acetylene sometimes behave as an acid and it's giving H to the base. So as you see here, NH2 is taking H, from the system. This H, it will be gone, and now those two electrons, they will be given to carbon. Okay, I will get here, I have an acid. Okay, I need to know the pKa for that acid is a 25, and I got the conjugate. Okay, I got the conjugate acid. Okay, I need to check the pKa of the acid and the conjugate acid. And the pKa for the acid, the conjugate acid is higher than the acid, and because it's higher, this reaction will move to the right side. Okay, now if we reacted with OH, the conjugate acid, it has a pKa around 16, while the starting one is a 25. So that means this reaction is not gonna move forward. In fact, it will go back. And then when we say, in this case, acetylene is not strong enough acid to give H to OH. So again, acetylene is not a strong enough acid to give H to OH. That means this reaction is not gonna happen. Okay. Can I turn alkene or alkyne to a saturated compound? Yes, we have a bunch of techniques that you can use them to saturate triple bond. And one of them is hydrogen and the presence of platinum. And in this case, we say there is no selectivity. What does it mean? It means if you have a double bond or triple bond, it will be simply saturated. So whether you have a single bond or double bond, double or triple bond, it will be saturated. And how many pi bonds? Here I have 2 pi bonds. That means I need to have 2 mole from hydrogen gas is saturated. So I need to have 2 moles, okay? Per each pi bond, 1 mole of hydrogen. And now, again, I said there is no selectivity. So say, for example, here we have a triple bond, and there we have a double bond, and then I add hydrogen gas to it. Okay, so I'm gonna say here I need 1 mole of H2O, and for those two, I need 2 mole of H2, 1 mole of H2 plus 2 mole of H2 there. So technically I need to have 3 moles. Okay, 3 moles of that one. And that's going to give me, it's going to give me completely saturated compound. So I go 1, 2, 3, 4, 5, 6. Okay, so here you go. 2, 3, 4, 5, 6. And my component will be completely saturated. And this is going to be hexane. Okay, again, there is no selectivity here. Do we have some catalysts that can selectively pick the double or triple bond? Yes, there are some, you know, catalysts that some of them, we call them lazy catalysts. They can actually saturate or reduce. Okay, they can reduce the system by only 1 pi bond. Okay, 1 pi bond. That means they can transfer only one mole of hydrogen. In this case, we say the addition is seen, or addition is seen. What does it mean? It means that, you know, like when you're adding the hydrogens, you're adding them from one side. Okay, those 2 hydrogen, as you see, they were added to the same side. Okay, there is a reason behind it, and like in the next chapters, when we were talking about and when we talk about the configuration, we will touch this subject again. Thank you very much, and have a great time.